So here we are, 4.1D is in delta, and we are on example 9 doing problem B, y equals x cubed minus 3x. And we're trying to find out if it's symmetrical on the y-axis, or the x-axis, the y-axis, and the origin. Okay, so it's very similar. It's going to be exactly the same as what we did on A in 4.1C. So let's just keep moving here. So remember, to find out if this is symmetric with the x-axis, all we're going to do is replace our y. So here's our original one. We're going to replace our y with a negative. Okay? So it's going to look like that. All right. It is not equivalent to the original equation because this is negative, or one's negative and one's positive, even though the rest of them are alike. And again, you will run into times where it is the same. So don't just assume that, oh, that's a no-brainer. It's never the same. No, that's not the case. Or they wouldn't even have come up with the whole idea. Okay, now let's look at the y-axis here. Let's look and see if it's symmetrical to the y-axis. And in order to do that, we look at the original equation and we replace every x with a negative. So for the y-axis, let's do this in red. It's going to be y equals negative x cubed minus 3 times negative x, which equals negative x cubed plus 3x. Okay, so it's plus 3x because the negative 3 times negative x is 3x. Negative x times negative x equals a positive x, and it says do it 3 times. Negative times a positive is a negative, so that's where this one came from. Okay, just in case you needed a little bit of a reminder of how that came or where that came from. So now what we do is we look and say, okay, is this equal to our original? Okay, no it is not. So therefore it's not symmetric to the y. Okay, so let's see if it's symmetric to the origin. And this is where we replace x with negative x. That's a with sign, kind of like that. And y with negative y. All right, so this is what it's going to look like. Let me erase this so I've got some room to write here. I need a bigger screen on my iPad. I was looking at Dell. Dell has some with 24-inch screens. It sure beats the heck out of this little 9-inch screen. Okay, anyway, so we have our original one, which is y equals x cubed minus 3x. And our new one, where we're replacing the x and y with negatives. So negative y equals negative x cubed minus 3 times negative x. So again, this gives us negative y equals negative x cubed plus 3x. Now, this is a key thing here. Notice what we've got. Every term here is the opposite of here. Okay? I can legally, mathematically legally, change the sign of this to y if I change every other sign. So I'm going to do this in red. I'm going to change that to a plus, change that to a plus, and change that to a negative. I can do that. And that gives me y equals positive x cubed minus 3x, which is the same as our original. So therefore, it is equivalent to the original and is therefore symmetric to the origin. And because it's symmetric to the origin, it makes it an odd function. So an even function is symmetric to the y-axis. Odd means it's symmetric to the origin. All right, so if you do letter C, you'll find out, just look at 257, right-hand side, does basically the exact same thing follow the ideas that I gave you, especially for the homework that is on pages 260, or page 260, 39 to 52. Now 39 to 46, you're finding out whether they're symmetric to the x-axis, y-axis, and or the origin, because sometimes it's more than just one. So you can't just stop once you find it's symmetric to the y-axis. Well, it could also be symmetric to the origin. So don't assume that once you find one, you're done. You got to do all three of them. But exercises 47 to 52, you're not only determining what they're symmetric to, but they're asking if they're even, odd, or neither, which means you're going to have to find out what they're symmetric to. So if they're symmetric to the y-axis, you know it's even. Symmetric to the origin is going to be odd. Okay, so just something to consider there when you're doing your homework with 4.1, and that's it.